34.4 standard enthalpy change of formation. Okay, that will be the last standard enthalpy change of reactions that we're going to talk about. So quick revisions. Okay, previously we have learned two of them. One would be standard enthalpy change of C, stand for combustion. So the definition is very important. When 1 mole of substance is burned completely in oxygen. 1 mole of substance is burned completely in oxygen. Okay. Also, you have to stay understand the conditions and the others. And remember, when you write the thermochemical equations, the reactant to be burned have to be 1. Okay, in this case. Okay, so it always be negative because it's an exothermic reaction, while the other one is standard enthalpy change of neutralization. So when 1 mole of this time is water is produced from neutralization between an acid and alkaline under standard condition. Again, okay, the definition you have to bear in mind. Remember, the target is water this time, so therefore you can see that, okay, 1, okay, it goes to 1 water form. Okay, so even you have like H2SO4 and NaOH, remember the balancing, okay, have to be H2O and A2SO4. Remember, all these have to be remains by half, so therefore you can keep this one by 1. Okay, so exothermic reaction as well, so therefore you can see that it will be negative. It will be negative here. Okay, so in general, strong acid, strong alkali will be negative 57.3, while the others, okay, it will be like less negative. Okay, because some energy required to completely ionize, okay, the weak acid and weak alkaline. Okay. So next we're going to have a look of standard enthalpy change of formation. So this time is formation, so therefore the symbol will be F. Okay, so definition. Standard enthalpy change of formation is an enthalpy change. Remember, composed of 3 parts. First part, enthalpy change. When 1 mole of substance formed from its constituent elements in their standard state. So this will be the key for this point. Okay, and the last one, okay, will be under standard condition. Remember, this symbol, okay, means under standard condition. Okay, so what it means by formed from its constituent elements in the standard state, we can have a look of example here. Okay, so if we write a symbol for that, okay, it will be standard enthalpy change of formation. The target that we have talking about is water. That means if we want to form water, okay, from its constituent elements, you can see that we have 2 elements here. One is H, one is O. Okay, so we will have H plus O to form H2O. But remember, these H and O, these elements, okay, we have one condition: they have to be under their standard state. So think about H and also the standard state of H. Okay, for H, okay, it should be H or H2. We know that, okay, it should be a diatomic molecule, so it will be more stable. O, O2, and also O3. Which one is standard state? We also know that O2 will be standard state. So that means that to form H2O, okay, they will be a combination of H2 and also O2. Okay, but because we have to make H2O to be 1, okay, so therefore when we do the balancing, okay, the O2 will reduce by half like this way. Okay, so that will be the definitions, okay, of formation. So we can have a look of another examples. For example, the NO2. So you find that this one, okay, we could represent by NO2 like this way. Okay, so again, okay, it is formed from N and also O2. So the N, okay, in standard state it should be N2. So therefore you can see that this one will be N2, okay, and then O2. So this is the focus. So therefore, it will have to be 1 all the time. So other thing I want you to pay attention to is the symbols, okay, the sign for the value. So for this one, okay, it's negative, and for this one, it's positive. So therefore, actually for formation, it's different from the neutralization and combustion. For the other two, they have to be negative all the time. But for formation, it really depends on what product you're going to form. It can be sometimes negative, sometimes positive. Okay, so for the features of these experiments, for these values, okay, first of all, you have to know that the substance to be formed have to be 1, and also the value can be positive or negative. Other than that, okay, do pay attention. You are required to memorize the definition, okay, of standard enthalpy change of formation. Okay, so standard enthalpy change of formations. Okay, if we talk about elements, okay, we have to consider these elements. Okay, whether they are are in their standard state or they are not in their standard state. Just now we have an example. For example, O2. If we are talking about O2, that we will know that O2, okay, because the standard, it is already is a standard state. So therefore, from O2 to become O2, that means they're not changing at all. So if we draw an enthalpy level diagram, you'll find that they are just at the same position. So in there, okay, it is not difficult for us to know that, okay, it will be 0 kilojoule per mole. Okay, if it is under standard state, it will be 0. 0 means that no heat change involves because they are not going to change to other things. But if we are not having, we are having the elements not in their standard state, say for example O3. For example, we know that diamond is also not in their standard state. Standard state of carbon is graphite. So at that time, okay, that will be non-zero. Okay, so for example, okay, if we have a diamond, okay, that will be from like graphite to become carbon diamond. Because they are not the same substance, okay? So therefore, when graphite go to diamond, okay, it will be a positive 1.9, okay? You can see here. It will have a small changes in that formation. You say, oh, that is very little amount of energy. So just per mole, just like 1.9 kilojoule. Do remember, okay, at this moment, we haven't learned another important concept. But actually, if you need to change graphite to diamond, you may have a very, very high energy obstacles you have to go through. That one, later on, we'll learn that one is called activation energy. So don't be so naive, think that, oh, from graphite change to diamond, just like 1.9 kilojoule per mole is easy to turn it. Sorry, okay, you still have a great energy barrier that you have to go. But this one, okay, we'll learn it later. But the key point is, okay, if it is a standard state, okay, if the element is in standard state, the formation will be 0. But if the element that you're looking at, okay, they are not in their standard state, then it will be non-zero. It can be positive, okay, like this, or some of them normally won't be negative, okay, because if it's negative, that means it will be much stabler than the others, right? Okay. So have some practice, okay, of thermochemical equations, okay. Remember the sign, okay, can be positive, negative, so really depends on what elements you're talking about. Some of them is negative, some of them is positive, okay. So quick one, okay, we have look of like formation of NaHCO3. So for this one, you have Na, you have H, which is in H2, you have C, and you have O2 as well. So this one will become NaHCO3. Okay. So this one have to be 1. Remember, you don't need to write this out. Okay. I just want to remind you. So for the rest, okay, you just have to multiply them and also write down their correct state. You may say, oh, do I need to write solid and then comma graphite? If you can, it will be fine, okay? But if you just write solid, I don't think the others will going to have mark deduction from you. Do remember at the end, okay, you have to write down, okay, formation. It will be negative 947.7. A unit is kilojoule per mole, okay? So we use the same method, okay, to deal with the others. Say, for example, for the calcium carbonate, then it will have like 3/2, and then they form calcium carbonate. Okay. Remember, okay, thermochemical equation, you must include the state, okay, and then you just have 1207 kilojoule per mole. So every time will be like that, okay. So for NO2, half O2, half N2, become NO, that would be gas state, and gas state. And the last one, okay, you have like CH3CH2OH, so you got 2 carbon, you have 3 H2, and then you have half O2, and then you form ethanol. Okay, so basically, okay, the formation will have to, the equation have to be written like that, and that will be one of the key questions that you can see in standard enthalpy change of reaction. So it requires you to write down the equation. So quick look of our class practice. Okay, part 1, okay, you need to use table. Okay, I have provided you the table already. Just determine the enthalpy change of reaction for each of the following reactions. So first of all, you see that this one, okay, H2 plus Cl2 become 2 HCl. Okay, we got 2 here. Okay, so this one will not be a it is not 1. So if you check back the equations, okay, this one equation is a formation equation, because this one is formed from its constituent elements. Just this coefficient is not 1 only. So for what we have to do, okay, if we go once to form 1 HCl, is releasing 92.3. Now we're going to form 2 HCl. So basically for this one is 92.3 times 2. Okay, so this one should be negative 184.6 kilojoule. Okay, and then B, okay, 2 carbon H, 4H2 and O2. Again, you're going to form 2 methanol. So for this one, you just need to multiply this one by 2. And then for graphite, go to diamond. Graphite, go to diamond. Remember, graphite is the standard state. This one is the standard state. So therefore, they are not changing in between the elements which have the same standard state. So therefore, when graphite go to diamond, it have to be absorbed 1.9. So therefore, this one is 1.9 kilojoule. And next, okay, you are going to form 2 carbon monoxide and 1 carbon dioxide. Basically, for part D, you're going to form 2 carbon monoxide. So you have this one times 2 and form 1 carbon dioxide, so this one times 1. So you add these two things together, will be all right. So it will be 110.5 times 2 plus, okay, you have 393.5. Okay, so this one, if you add it up, okay, will be negative 614.5 kilojoule. So enthalpy change, I don't agree this part, okay, they have per mole here, to be honest, okay, because enthalpy change, okay, it will be just kilojoule will be all right, okay, because this one you have already multiplied this by 2 mole and things like that, so the unit of mole have to be this eliminate, okay, in the process. So question number 2, based on the information table 33.1 and 34.3, what a balanced thermochemical question for each of the following reactions. So the first one, okay, it is HCl and NaOH. So this reaction is a neutralization. Okay, so therefore you have to check about the thermochemical standard enthalpy change of neutralization. But we all know that this is strong acid, strong alkaline, so you should be able to memorize 57.3 kilojoule per mole. Okay, so this one is per this mole, so therefore it will be per mole. Okay, and then B, burning propane completely in oxygen. Propane should be C3H propane, 8, okay, O2. Remember, this one have to be keep 1, so therefore you have 3 CO2 and also 4 H2O. So in total should be 10 O2, so you have 5 O2 here. Delta H, remember, you try to put this back down like standard enthalpy change of neutralization, standard enthalpy change of combustion. Okay, so for this one, okay, we have propane, it will be negative 2220 kilojoule per mole. Okay, again you have to per mole because it is per unit mole of propane. Last one, okay, that will be ozone go to from oxygen, so you have oxygen go to ozone. So this one, because this one is the formation of ozone, this have to be 1, and then you have to be 3/2 for this one. And for ocean formation is positive 143 kilojoule per mole. Get it? Oh, so query for these 3 videos. Okay, so remember, you have to remember the definition. For combustion is a completely burn in oxygen. For neutralization is water produced from neutralization. For formation should be formed from its constituent element. In standard state. Okay, remember all of them will be under standard condition. Okay, so the target, okay, the target one, okay, must keep 1, must be 1 all the time. So for combustion, you're talking about the fuel. For the neutralization, it'll be talking about the water. For formation, it should be the substance. Okay, for the values, okay, you will find that combustion must be negative. Neutralization, okay, it is also negative, and most of the time it should be negative 57.2 or 57.3, both all right, okay? But sometimes, okay, it will be less negative, less energy release, because when you add some weak acid or weak alkaline right there, okay, so some energy is used to completely ionize the weak acid and weak alkaline. But for formation is something different, okay? They should have positive or negative, both value, or will be possible, okay? So that's all for this video. Bye bye.